how's it going? It's Liz from the growth team here at the Definity Foundation. Today, we will be having a community conversation with Principal Engineer John Wiegley on staking on the internet computer. So without further ado, I will hand it over to John. So take it away, John.
Thank you to everyone for joining us today. I wanted to talk with you about staking on the internet computer and what staking is about, why you might want to do it. I will put in this disclaimer at the beginning that this presentation is not meant to encourage you or discourage you from staking. I merely want you to have the tools and information necessary to make good decisions if you do choose to stake. But nothing in this talk should be taken as financial advice or a recommendation that you ought to stake. So what is staking on the internet computer? Staking is the primary means by which you participate in the voting on proposals which are used to change the nature and the operation of the internet computer. So anytime something is going to happen which alters the fabric of the internet computer, such as bringing new computers into the network, new subnetworks online, changes in tokenomics, all of this, they are submitted as proposals to the network, and those proposals are voted on. The votes are counted from among the stakeholders, and a majority wins, and it becomes a change affected in the internet computer. So in order to have an influence on the future of the internet computer and how things evolve, we need stakeholders. We need people who are willing to put some of their ICP, or the tokens that they have, into the network and have them rest there so that they can gain voting power and have influence over these proposals. In compensation for having your ICP locked up in this way, the act of voting generates rewards for your staked position. And this is a compensation for your tokens being illiquid for a certain period of time. The longer they're illiquid for, the more voting power those tokens are going to have, but you will also then not have access to being able to trade those tokens for that period of time. Before I go deep into the mechanics of staking, there's just one thing I want to say briefly about security. Because you might be staking large or small sums of ICP in the network, you should be very conscious of how it is that your ICP is secure within the staking mechanism. If you have a seed phrase, and you may not because you might be using a custodial service such as Coinbase Custody or Signum, but if you do have a seed phrase, you should know that all of the details that I'm going to be talking about whenever I say public keys, principal IDs, account numbers, Neuron IDs, all of these things, they all derive cryptographically from your seed phrase. The seed phrase is quite literally the keys to the kingdom. And if anyone has access to your seed phrase, they have access to everything that relates to your ICP and your accounts. We only need a private key to sign and submit transactions to the network. So the private key is the thing you're generally going to be interacting with on your computer, whereas your seed phrase will usually be kept off the computer in something like a seed wallet, or written down in some secure location, kept in a safety deposit box, whatever it is that you need to do to make sure this seed phrase is never seen by any eyes but your own, but is retrievable in the case that should anything happen to your private key and you're not able to access your tokens from your computer anymore. So just to keep in mind, the security of all of this relies upon cryptography, and the seed phrase is the key to all the cryptographic elements that will be associated with your neurons and with your staking account. So a little brief summary of voting power. When I stake, say, 100 ICP into what we call a neuron, and a neuron is a special type of account that has this voting power associated with it and is able to vote on proposals. So the neuron, you can think of it as a wrapper account around some amount of ICP, which is kept illiquid. That 100 ICP has a voting power of 100. Then there are certain bonuses that may apply depending on how large that stake is being held for, how long it's being held for, and how long it's been in the neuron. So I'm going to go into detail on these bonuses and how they're calculated, because your decision of, well, how long should I keep my ICP locked up for, that may relate to what kind of bonuses you're expecting to get on your voting power. Rewards are minted and available to your neuron every day. However, they cannot be taken from the neuron as liquid ICP until you have accumulated at least one ICP of value. But each day, after all the voting has happened that day, each neuron that's been able to participate in voting will have voted on a certain number of proposals. Let's say you have set your neuron to vote on everything that the Definity Foundation votes for. then it's very likely that you will have voted on everything. That's 100%. So in that day, because you voted on 100% of the available proposals, you're eligible for the full reward allocated to you according to your voting power that day. And this happens every single day. Voting maturity is what we call these accumulated rewards, and I'll be going into that terminology later, but maturity is updated every day. Now, calculating the return, this is a very commonly asked question on social media forums, such as Reddit. People want to know, if I stake my ICP, how much will I get? This is something that we cannot predict with accuracy into the future. It can be said how much the reward accrual is today based on what's been actually happening, but we can't say what it's going to be 1 year from now, 10 years from now. So although you have the option to lock up, say, a certain amount of ICP for 8 years, there is no telling what the return will be in 8 years from now. Today, people are getting a return for an 8-year lockup of around 29, but that could be 5% in 8 years. It could be 10% in 8 years. No one knows. Also, because this is a network that is designed to evolve, as I said before, through the mechanism of proposals and updates, anything can be updated. So tokenomics can be updated. The way that neurons calculate return can be updated. All it requires is a majority vote from the stakeholders, and those updates can happen. So the future is not set in stone. And the amount of your return is going to depend not only on the amount that you stake, but how long you stake it for, how long that neuron has been aging, but now also on external factors, like what is the total supply of ICP in the network? At the moment, we have around 471 million ICP as total supply. So rewards are going to be calculated off of that figure. But through inflationary and deflationary mechanisms built into the network, that number is going to go up and down. As it goes up, the piece of the pie gets bigger for stakeholders and their rewards. As it goes down, it will get smaller. That's something that cannot be predicted and has nothing to do with the choices you make around your neuron and your staking decisions. So just to keep in mind that there are internal factors that affect your rate of return, and there are unpredictable external factors that affect your rate of return. Now, base rewards, where do rewards come from? So each day, the total supply is considered, and a percentage of that supply, which right now is around upper nines, 10%, and that's divided into 365, so we get what the amount should be for today. We take that amount of ICP and it gets divided up among all of the neurons that voted that day, according to how much they voted and how much their voting power is. And then that is the reward accrued to each neuron. Right now, this base calculation is done off of 10% of supply. Very generous. It's starting out with the beginning of the network and wanting to incentivize people to become stakeholders and participate in voting. But this base calculation is going to lessen over time. The first 8 years of the network's lifetime, we'll see it drop from a 10% of supply reward to a 5% supply of reward. And then, unless tokenomics is changed by a proposal, it will remain 5% thereafter. You also are competing with other stakeholders, in a sense. The more people who stake, the more that reward is diluted among all of the stakeholders. So right now, another reason why rates are very high is that there are not very many stakeholders. And that's why we want to have presentations like this one to show people what this is all about, to see if they would be interested. So what is a neuron? I mentioned that a neuron is a special type of account. Formally, we can define this as a ledger account controlled by the governance canister. So running on the internet computer, there is a special subnetwork with high replication factor called the NNS, the network nervous system. And this is where the metaphor of the neuron comes from. The network nervous system is responsible for shuffling through all the proposals and enacting the changes that they represent. So it keeps a ledger account, which has all of the accounts and ICP in those accounts. Some of those accounts are just regular transactable accounts, liquid accounts, and some are neurons. And neurons control accounts where they will lock up a certain amount of ICP, making it illiquid, with those rewards coming back as a result. So that is essentially what a neuron is. It can be thought of as a special account with a few extra data associated with it. So what are the attributes of a neuron aside from its account? Every neuron has an ID, and the ID is pretty close to being a random number. You shouldn't take too much from it. It's just a number to identify that neuron. It's a different number from its underlying account, so that is not the account that the neuron controls. Each neuron has an amount of stake, which is the amount of ICP that has been transferred into the neuron, or staked in the neuron, we say. There is a dissolve delay, which I'm going to cover in some detail. This controls how long it will take before the ICP that's in the neuron can be taken back out. So if there's a dissolve delay of a year, that's the minimum amount of time, not the maximum, but the minimum before that ICP can be removed again. The dissolve state tells us whether the neuron is currently dissolving towards the end of its delay and becoming liquid again, or is not dissolving and is simply in that state where it's seeking to have the most voting power. There is also a non-dissolving age. We incentivize people not to begin dissolving neurons immediately by offering a multiplier on their voting power for how long the neuron has been in the non-dissolving state. So let's say I stake a neuron, I set the dissolve delay to 1 year, and it's now in a non-dissolving state. So that 1 year is going to stay 1 year with every day that passes. I would have to begin the dissolve to then wait 1 year for it to become liquid. So while that 1 year neuron is in the non-dissolving state, each day it is accumulating age. And once it gets to 4 years, it will have reached the maximum age for that neuron, and it will have a 1.25 times multiplier on its voting power. And this is a multiplier on top of any other bonuses the neuron might have. And I'll give you an example of how that plays out in an upcoming slide. Next is maturity. Maturity is not related to something like a bond maturity, if you're familiar with other investments. Maturity is simply the name we give to reward that has been accumulated to that neuron. If you've seen maturity, the figure in the NNS app, it's displayed as a percentage of stake. It can also be thought of as an amount of ICP that has accrued to that neuron. It has no impact on voting power at the moment, and it is not immediately liquid itself. It has to be spawned from the neuron in order to become liquid at some point in the near future. But maturity is your accumulated reward. Followees and topics. So I said initially, the real underlying purpose for having neurons is to allow people to participate in the governance of the internet computer. Your neuron can now vote on any proposal that comes up, and you can manually initiate that accept or decline for each proposal. Another way of voting is to register another neuron as a followee for your neuron. And what you're telling the system is that every way that neuron votes, I will vote. So if you have a neuron that follows the DFINITY Foundation, for example, you will vote on everything the DFINITY Foundation votes on in the way that they vote for. That is a followee. Topics are different categories of proposals that you might follow or not follow a certain neuron on. So some topics relate to exchange rate changes, for example. Maybe you don't follow the DFINITY Foundation for exchange rate changes, but you do follow them for other topics. It's a very configurable system. And then lastly are hotkeys. Hotkeys allow you to have a read-only view of a neuron by a different controller than the controller that governs your neuron. The controller is, you can think of it as the private key related to the seed phrase when you created the neuron, when you staked it. That private key is the controller of that neuron. Only that private key can make changes to the neuron, like increasing its stake, changing its dissolve delay, starting the dissolve, etc. However, other controllers can be made hotkeys to your neuron, and then they will be able to see all of the details of your neuron, but they can't change it. Where this becomes really useful is in the NNS app. You might have a neuron that you created through self-custody, a self-custody mechanism that we're not going to cover in this presentation, but a future one. And that neuron you keep very secure by using an air-gapped computer before you sign your transactions, et cetera. But you would like to be able to very conveniently see what is the amount of stake, what is the amount of maturity, what have I been voting on? What you can do is using your internet identity, log into the NNS app, and then having made the NNS app's principal ID a controller for your neuron, you will now see your neuron in the NNS app, and you'll be able to see all the details of your neuron and how it grows over time. I have a little picture of what this looks like in an upcoming slide. So for now, I want to go over all of these attributes and talk about how they relate to your neuron and its voting power, just so that you can be more informed in your creation of neurons. So the stake, this is the simplest one. This is just the amount of ICP held in the neuron's subaccount. Stake can be increased at any time, whether the neuron is dissolving or not dissolving, however long the dissolve delay is, you can always add stake to your neuron. Withdrawing stake from the neuron requires that certain conditions be met. One is that its dissolve delay has fallen to 0 through the passage of time. And that is the only condition that you have to meet. So if the neuron currently has a large dissolve delay and is not dissolving, you begin the dissolve, you wait until the dissolve delay has been passed, and now you can disperse the neuron, which will bring all of that ICP back into the original account. Next is the dissolve delay. This is where people usually have to make the most decision in creating a neuron. How long am I going to set the dissolve delay for? It can be anywhere from 1 second to 8 years, but what you choose will have an impact on whether it votes, whether it can vote, and how much of a reward multiplier it receives. So there is a minimum time. Well, what the dissolve delay is it's the minimum amount of time your neuron must wait before the state can be withdrawn or dispersed back to the parent account. So even if it's a 10-second dissolve delay, it means I have to wait, and I have to wait for 10 seconds to pass on the clock before I can get that ICP out. Think of it as a time lock, like on a safe. The neuron must also be in a dissolving state for this delay to decrease. So if you've created a neuron with a 1-year dissolve delay, but you haven't started the dissolve, it's going to stay at that 1-year dissolve delay, no matter how much time passes. So it has to be in the dissolving state for the dissolve delay to be decreasing towards 0. The larger the delay you have, the greater the bonus is going to be to your voting power. Now you have to have a dissolve delay of at least 6 months to be able to vote at all. Any neuron whose dissolve delay is less than 6 months will not be liquid, but it will also not vote, and it will not accumulate rewards. So if you have a neuron and it's less than 6 months, likely what you're going to want to do is make sure that it's dissolving, or increase its dissolve delay so that it's over 6 months and can begin accumulating those rewards. A dissolve delay of 6 months offers you a bonus of about 1.06 times your voting power. So if you had 100 ICP in the neuron, you would get 106 voting power. This is because the voting power is scaled from 1x to 2x linearly over the span of 0 to 8, except only at 6 months can it actually vote. So the very first voting stage, it will be at 1.06 times. At 8 years, it will have a 2 times multiplier on the ICP. So if I stake 100 ICP, I get 200 voting power. And anything in between that scales linearly. So you would be able to do the math and find that at 4 years, you will have a 1.5x multiplier. The dissolved state of a neuron is either in the dissolving or non-dissolving state. A fully dissolved neuron could also be said to be non-dissolving because its delay will not be changing. If it is a dissolving neuron, the delay until liquidity, or your dissolve delay, decreases with each second that passes. A non-dissolving neuron with no delay is dissolved. We call that dissolved, and that can be dispersed back into your parent account. But only non-dissolving neurons accumulate age toward their age bonus. So if I have a dissolving neuron, I will give up all of the age. And I'll just go to the next slide because this talks about age. What is age? If I have a 1-year neuron that is not dissolving, and I've had that neuron for 4 years, it is said to be 4 years old in the non-dissolving state. If I then start dissolving that neuron, I instantly lose all of that age. It becomes like a newborn neuron. If I then stop the dissolve and I go back to the non-dissolving state, I'm still starting at 0 with respect to the age. So it's important to only start the dissolve when you're sure you want to dissolve to liquidity. The first 4 years of a neuron's aging cause it to accumulate a voting power multiplier based on that age, which is scaled from 1 to 1.25x. So if I have an 8-year neuron with a 2x voting power multiplier, and it's been in the 8-year non-dissolving state for 4 years, then I will have 1.2x on top of that, or a 2.5x total multiplier on my ICP. And this is the largest multiplier that you can have at the present time. To give you a little clearer picture of what all these different states sort of imply, we have voting neurons, those that are in have a dissolved delay beyond 6 months, whether dissolving currently or non-dissolving, they get to vote. Then there are non-voting neurons, which is dissolving or non-dissolving under 6 months. And then we have those two categories of neurons, those that are dissolving towards 0 and those that are not dissolving. So what happens for each of these states is that if you are a voting neuron, you have a delay more than 6 months, and you're non-dissolving, well, you earn reward, you have a delay bonus, you're gaining an age bonus. The only detrimental factor in that case, your ICP is illiquid. But you've chosen that as an investment because you want to have influence on voting for proposals. If you have a voting neuron that's dissolving, it also earns reward every day. And it also has the delay bonus based on how much delay is left, but it will have no age bonus. A dissolving neuron never has an age. However, it's becoming liquid. At some point in the future, you will be able to retrieve that ICP. For a non-voting neuron that is non-dissolving, this is not anything anyone ever wants. And hopefully at some point in the future, we will just make this state invalid so that anything with a dissolved delay that's too small just goes automatically into a dissolving state. That's still under discussion. But as you can see here, you get no rewards in that condition. You have no delay bonus, you have no age bonus, and you're illiquid. It's just like locking up ICP with no other benefit. If a non-voting neuron, however, is dissolving, it may also not have any rewards or bonuses, but at least it is becoming liquid. Finally, when it reaches a dissolved delay of 0 seconds, it is a dissolved neuron. Dissolved neurons have no rewards. They have no delay bonus. At present, they have an age bonus. They do still age. This may change in the future. And they are liquid. They can be dispersed back into the account. So to summarize all of this that I have said about voting power and bonuses, your base voting power is the amount of ICP you have staked. 100 ICP, 100 voting power. You get a delay bonus that scales linearly from 1x to 2x based on the amount of delay in the neuron. It only has an effect on voting power if it's above 6 months. So I will say that it scales from 6 months to 8 years, but really it does scale from 0 to 8 years. Then there is the age bonus, which is the time since you entered the last time you entered a non-dissolving state. And it only has an effect on voting neurons because it's a voting bonus. This scales linearly from 1 to 1.25x. It is multiplicative, and it's based on your non-dissolving age of that neuron from 0 to 4 years. I realize this is a bit of math on this slide. We get a lot of questions about these equations on Reddit, but if you think about how much delay do you have in your neuron and how old your neuron is in terms of how long it has been in a non-dissolving state, you should be able to calculate what your multiplier is. Now I want to look at an example of an 8-year neuron. Let us say, for the sake of argument, that a certain amount of ICP has been vested to me, for example, and I decide I want to put it all into an 8-year neuron. So when it comes to me, the ICP, it's in my account and it's tradable. And that's my liquid account, the master account that's related to my seed phrase. At some point, I decide, you know what, I'm going to stake all of this ICP. I'm going to make it 8-year neuron. Let's say it's 100 ICP. I'm going to stake it in an 8-year neuron. When you initially stake, your ICP will be in a neuron that has 0 dissolve delay and is not dissolving. So the first thing you'll have to do is increase the dissolve delay by adding delay time to it. In a future presentation, we'll show how to do this for the different schemes that exist for staking. Right now in this presentation, I just want to talk about the concepts. So I add dissolve delay to my non-dissolving neuron that I just created, and that makes it now a non-dissolving neuron at 8 years of delay, which means I instantly go to the 2x multiplier on voting power. As you can see here in this little graph at the bottom, I start out at 2x because I have an 8-year neuron and my ICP are there. As this neuron ages in the non-dissolving state and having 8 years, it will start accruing age bonus, a multiplicative age bonus. So it's going to keep creeping up for the first 4 years until it gets to a 2.5 times age bonus. on top of the delay bonus. While that is happening, I am free to claim the rewards as they accrue. So if it's 29% right now and I have 100 ICP, it means in a year I'll get 29 ICP. Every time that there is one ICP worth of rewards sitting in that neuron, I can spawn it out and take that ICP and trade it. So I'm repeatedly claiming my rewards over this period of time. When I get to 4 years of non-dissolving age, my 8-year neuron is now at its maximum voting power bonus and stays there if I don't do anything else. And I just keep getting the voting rewards as if I had 250 ICP of voting power. Now, let's say that it's been 12 years and I decide I'm going to start dissolving this because I want to liquidate that account. So I will then start my dissolve. Starting the dissolve will instantly take the age bonus off the board, and it will drop me back to a 2x age bonus based on the delay alone. Over the next 8 years, because that is the length of the dissolve delay, I will start dissolving. So each day it will be 1 day closer to 0. So the delay bonus will start dropping linearly with time. And it will go from 2x on that day when I started the dissolve, heading down towards 1x when it gets to the 6-month marker. When I get to the 6-month marker, I'm no longer a voting neuron. Now rewards disappear. So for the next 6 months, there will be no rewards. I cannot vote. Proposals will just pass me by. When the 6th month has finally completed, I now have a dissolved neuron. And at any point in time, I can choose to either increase its stake, increase its delay back to what it was again if I want to, or I can disperse it. And when I disperse it, it goes back into the same account where things originally started, where I had staked from. So that sort of shows you how the multipliers will change over time as I'm interacting with and changing the state of my neuron based on my own financial planning and what it is that I decide to do. So maturity, I said that maturity is roughly the unclaimed reward in your neuron. It's not an exact figure. When you actually spawn, it may be slightly different. But if you calculated it, if you multiplied the percentage figure you might see in the NNS app with the total stake, there's not a guarantee it's going to be exactly that amount, but it's going to be very close to it. There are certain factors that only get determined at the moment of the spawn. Maturity, even though in the real world, maturity is something you accumulate with age, the age I've been talking about in terms of the age bonus and having a non-dissolving age has nothing to do with maturity. Maturity is simply a word to describe unclaimed reward in the neuron. And this unclaimed reward does increase with time and with voting. And that's where the concept of maturity came from. But I want you to keep clear in mind that the age bonus and the maturity are two entirely unconnected terms. Now, each day that you participate in voting, if your neuron's dissolve delay is greater than or equal to 6 months, whether it is dissolving or not dissolving, then you will be accumulating maturity for each of those days if you are voting on proposals. If you're not voting, you might be eligible for reward, but you won't get any reward. If you only vote on a few proposals, but not all of them, you'll only get a fraction of the reward you could have on that day. We call claiming maturity spawning in the different interfaces and tools that we have built. So if you hear the term spawning, that means turning the unclaimed reward in the neuron into ICP by moving it into a new neuron, which starts out with a dissolve delay of 7 days in the non-dissolving state. So you would then start the dissolve on that 7-day neuron, and then 1 week from now, that ICP could be transferred back into the parent account from which all of this began. So for some people who are going to be staking for a long time, you're likely to be in a habit of this reward harvesting, whether you do it weekly or monthly, whatever works for you. So I kind of wanted to draw this out in the form of a graphic, the cycle of a participant in stakeholding. So you have your original account from which you staked ICP, and then you increase the delay. This shouldn't be daily, it should be delay. So you increase the delay to make it a voting neuron, because as I said, when you initially stake, it starts with a delay of 0. So you need to bump that up to at least 6 months. Now you have a non-dissolving neuron at or above 6 months, and it's going to be accumulating reward. So there's two things you could do. You could either spawn that reward once you have enough of it, and then start the dissolve on this reward neuron. Or a new feature that is coming soon is, we call it merge maturity. So with one button, you will be able to say, you know what, take all of that maturity and just add it to the stake of my neuron, changing nothing else, not changing the delay, not changing the dissolve state. That should land relatively soon, but I can't give any accurate predictions on when that will happen. Whenever we make changes to governance or tokenomics, it goes through pretty intensive security reviews. So that dissolving reward neuron, which is the way that you would do it today, after 7 days have passed, becomes a dissolved reward neuron. Now it's like a special account. You can just take the ICP right out of it the way you would with another account. You just use a special command called disperse, and it moves that ICP back into your account. And now if you wanted to, you could put that maturity back into that same non-dissolving neuron, and in that way compound. We're hoping that merge maturity will make that type of compounding scenario much, much easier. Followees and topics. This is where you set your neuron to follow other neurons. Otherwise, voting has to happen manually. And there are a lot of proposals at times, which you may be a fire hose that you're sipping from. So it is good to find some neurons whose policies or the way that they vote accords with your own beliefs of the future of the network, and to follow those to ensure you get maximum rewards. But you don't have to. You can also just keep a neuron in reserve only for when you want to vote on the things that matter to you. There are two major candidates right now for following that you will see in the NNS app if you use that for setting your followees. That is the DFINITY Foundation and the Internet Computer Association. The Internet Computer Association is the association that relates to all of the node providers and the people providing hardware to the internet computer, whereas the DFINITY Foundation, we work on the core protocol and we're involved in those types of decisions. Setting the followees allows you to, your reward, of course, as I said, depends upon the percentage of possible votes you make each day. And you want to set your followees ideally so that you vote on as many proposals as possible each day and maximize your potential reward. Adding a hotkey, this is the little graphic I wanted to show you. This is what it looks like in the NNS app after you've added a hotkey. If you go to the Neurons tab, it will show you that list of your neurons. You will see in that list what will look like a neuron, except it has this hotkey control marker under it. And that means that this is a hotkey to another neuron living in a different account and is not directly controllable by the NNS app, except as relates to topics and followees. Here you can see that this neuron that is being hotkey controlled has 0 ICP in it and is fully dissolved, and using the term unlocked for that. Once you have a neuron, what are all of the things that you can do with it? You can increase the stake at any time. You can refresh it, which is just topping it up, adding more stake. So stake here usually refers to creating the neuron the first time. Refreshing refers to adding stake to an existing neuron. You can split a neuron. You can say, well, I have this neuron with 100 ICP and it's got a 6-month dissolve delay, but I'd like to sell 10 of those ICP. So since you can't withdraw ICP from a neuron, but you don't want to dissolve it all, what you can do is you can split off 10 of those ICP. And now you will have 2 neurons, both with a 6-month dissolve delay in the not dissolving state. And you can start the dissolve on those 10 ICP. And in 6 months, you can make that liquid. So you can create a very, very large neuron and carve off pieces of it as you need to liquidate. You can spawn or claim rewards, as I mentioned before. Dispersing is the act of taking the ICP in a dissolved neuron and moving it back into the parent account from which the neuron was initially staked. Starting and stopping the dissolve is another common operation. Again, be aware that stopping the dissolve will erase any age bonus that you have, even if it's only momentarily. So be very careful with clicking that stop dissolve button until you're sure you want to dissolve to liquidity. You can increase the dissolve delay anytime. So if you have a 1-year dissolve delay and you realize I don't need those ICP for the next few years, increase it to 2 years, increase it to 4 years. You can do that anytime. You just can't decrease except through the passage of time. You can add and then remove hotkeys at any time. So if somebody wants to see the details of your ICP for, some financial organization wants to confirm some detail of your neuron in the far future, who knows what's going to happen, you could add their controller key as a hotkey to your neuron, that would give them visibility into the neuron, and then you could just remove it. Two other features that are currently being worked on, as I mentioned, merge maturity, the ability to put your maturity right back into the neuron as increasing its stake, and then merging two neurons as the opposite of the splitting operation. Those are both underway. All of this is open source. So if you wonder, for example, exactly how voting power is calculated, I have a link right here. You can go see how it's done in the Rust code. How I learned everything in these slides, exactly from that source. I've been reading the Rust code for all of the governance and NNS related activities for several months now, which is why I wanted to make this presentation to digest some of this information for you. But it's very nice and clear in this file. It's not a huge file either. It's only, I think, maybe 1,200 lines long total. It covers more operations than simply staking. But if you want to know how splitting of a neuron is done, or what are the conditions under which splitting might fail, this is the definitive source, would be to go to the open source code. And now I want to thank you all for paying attention. We're going to move into a Q&A section.
Cool. So thank you so much for that, John. So I know you were busy giving that wonderful presentation, but we did have a very lively discussion in the chat, and we have over 20 questions that we got. So we had posted a Reddit thread fielding some questions. We'd like to go over some of those and then move on to the live questions. So yeah, John, do you want to speak to this first question on the screen
Sure.
here?
So Benchmouse asks, I've been hoping to see an option to combine neurons. I created quite a few before there was a hotkey to add to stake neurons, and consolidating them would be very helpful. It would also be nice if we could have an option to automatically reinvest spawned ICP back into parent neurons or other neurons without having to manually do it. Maybe that would negate a need for the 7-day dissolve before reinvesting. Doing this manually for multiple neurons can require a lot of checking. So fortunately for Benchmouse, we are working on both of those features. His first question would be addressed by the neuron merging functionality, and the second will be addressed by the merging of maturity functionality. I do expect merging of maturity to be released sooner than merging of neurons, only because merging of neurons has brought up lots of little edge cases that we found, and we would like there to be no new edge cases discovered for quite a number of weeks before we consider that a stable enough feature. The next question from Reddit, Buff Dark Knight asks, if I stake for 6-month dissolve delay and unlock right away, I won't get any rewards. So why not make it that 1-year staking is the minimum? New holders may stake 6 months and unlock right away only to find out they don't earn anything. What is the rationale behind this? And for any holder that staked 8 years, they may be questioning why the last 6 months doesn't have a reward. Why doesn't the team just remove the last 6 months concept and split the same staking rewards they would have received evenly throughout the 8 years? Although the rewards would then be the same, no people would question it. I do want to say that having a 6-month dissolved neuron is useful. I use one. All of the maturity that my 8-year neuron produces, I move it all into a 6-month neuron because I don't intend to sell anything for the next 6 months, but I would like to have a 6-month accessibility to that ICP. It still earns right now about 15% APY. So having a 6-month neuron, you just have to be careful. Don't start dissolving it. If you intend to stake and begin dissolving right away, then yes, do not pick 6 months because you will not do anything except just lock your ICP away from yourself. As to why that last 6 months concept exists, we do not want the case where somebody with a large amount of financial resources is able to create a neuron, which gives them a great deal of voting power, influence a proposal that's come up for vote, and then step out of the process by withdrawing their ICP. We want there to be a minimum 6-month investment in the network in order to have an effect on proposals and voting for proposals. So don't expect the 6-month window to disappear anytime. It is a way of guaranteeing that you have skin in the game. All right, let's open up QA to our live participants.
Excellent. So John, like I mentioned, we do have 20 questions. So let's do a little lightning round to try to get through all of the questions here. So the first question is, can we accurately calculate the rewards given the supply of ICP, the numbers staked, etc.? How are these parameters determined? And could we calculate estimates of rewards if we knew all of the specific parameters?
I believe that the system is too chaotic to allow any type of prediction to be viable beyond just a few days. We can take the data we have today and make an estimate into the future, but the quality of that estimate is going to degrade sharply as you go further into time, because there will be deflationary forces you can't predict. There are inflationary forces, such as when we mint ICP to pay node providers. You would have to be able to predict how many new node providers are going to come online, et cetera. So I do not think that there is a way for us to give estimates that are accurate enough to base financial decisions on.
Okay, thank you, John. So you had just mentioned that it's possible to merge maturity. Is this something that you will be able to easily enable and disable at any given time?
It will be a button in the NNS app, for example, and it will just say merge maturity. And when you click it, all of the accumulated maturity just goes into the stake of your neuron. It's totally up to you when you do it, how often you do it.
Cool, thanks, John. So the next question has already been answered in the chat, but since people watching after the fact will not see the chat, I'm going to repeat it here. So right now, the 8-year staking rate is close to 30%. Will this change? What factors impact the percentage?
It will absolutely change. I told you that base rewards are calculated as 10% of supply, and that declines to 5% of supply in 8 years. So if all other things stayed equal, that API would drop in half over the next 8 years. But it's also going to drop as more people begin staking, and there's more competition for the rewards being derived from supply. It will also change based on how much inflation or deflation we see. ICP get burned when people need cycles to run their canisters. If we have lots and lots and lots of activity happening on the internet computer in the future, fingers crossed, that will be a deflationary force because it will reduce the amount of supply, which reduces the amount of ICP available. However, this is all counterbalanced by how these things also affect price. So deflationary forces may tend to increase the price, and so the total value of your neuron may increase more than it would simply through the reward calculation.
Cool. Thank you, John. One question. So around terminology, things like spawn, neuron, or maturity or dissolve delay may not be immediately obvious to people who are not familiar with the NNS. Would it be possible to change some of this terminology to be a bit more friendly for lay people going forward?
It's a good question. It's a little tricky because what is familiar to different people is not as familiar to others. So perhaps the best way forward, since we already have these terms baked into our literature, into the source code, into the way proposals are constructed, would be to create glossaries and more material like this webinar to educate people about what is meant by those terms.
Cool. Thank you, John. So regarding proposals within the NNS app, how can people stay informed about what the proposals are concerning? Because it might not be clear to everyone what exactly is being voted upon.
Yes, this is something that is going to be improving in the very near term. At the moment, proposals are very brief, and it's sometimes difficult to find out exactly what an upgrade proposal is going to do. You may not have full access to the source code that the SHA that proposal points to contains. But this is very, very important for effective governance and full participation. So do expect a lot of improvements about transparency and clarity of our proposals and what they mean.
Cool, thanks, John. And then is it possible to merge neurons, and is it also possible to transfer neurons to somebody else?
Merging of neurons is being worked on, but is not currently possible. Transferring of neurons is not being worked on and is not possible. And the reason why we do not want the transfer of neurons, that would create a neuron market, which again would allow people with large amounts of financial resource to adversely, possibly, affect the evolution of the IC by buying into large neuron positions, voting on a proposal, and then withdrawing by transacting those neurons.
And then follow-up question on transferring of neurons. If somebody were to theoretically submit a proposal saying that it would be possible to transfer neurons and a majority of people voted for that, then is that something that would be able to be enacted?
Yes. This whole network evolves by proposals, and there are no restrictions on what a proposal can contain. So this is very much intended to be a network that grows through the involvement of its participants and its stakeholders.
Cool. So the world is the neuron holder's oyster, so to speak.
Exactly.
So does Dfinity Foundation and the ICA vote on every proposal? How do people maximize the rewards?
They do vote on every proposal. So if you wished merely to maximize reward, you would follow those two and let them vote on everything on your behalf. I do encourage people, however, to become aware of the different proposal types and what's going through the network so that you can make more informed decisions on what you want your neuron to do for you and how you want to be represented.
Cool. Next question. Somebody said that within the NNS app, they would like to be able to search for neurons other than Dfinity Foundation and the ICA. What is the best way of discovering neurons that people might like to follow?
That's a great question. I think right now, perhaps the best way to do it would be to just ask on social media. If there's someone you recognize in the crypto space who has neurons, who has staked, ask them what their neuron ID number is, because you can follow any neuron ID within the NNS app interface. It may not appear in our list of eligible followees, but you're able to enter that neuron ID yourself.
Cool. And just to chime in with what you're saying, there will be a community conversation with Cycle DAO next week. And I know this is a very big topic for them. So definitely tune in next week if you want to find out more. Question for you, John. People who stake early on, are they going to have disproportionate voting power? And will the NNS ever be governed by early whales, thereby discouraging future people from staking?
At the moment, early stakers have a disproportionate influence merely because the bonuses are so good. And the rewards are so good, so their voting power is large. But as more stakeholders come in, there's 470 million ICP out there. Only a fraction of that is being staked at the moment. So your voting bonus may be the same, your voting power might be the same, but as other people begin to stake and more ICP comes onto the staked side of the equation, that will dilute your voting power, so to speak, because votes pass based on percentage of stakeholders, not absolute.
Great, John. Next question. So in terms of rewards calculation, you had mentioned that 10% of the supply is part of the calculation. Do you mean 10% of current total supply or Genesis supply? And if you mean the former, i.e. current total supply, does that mean if token supply increases every day, rewards also increase every day?
That's actually a really good question. I would love to defer that to one of the NNS engineers who's here on this webinar call if they're able to answer that. I don't know if they have access to the chat, but I do not know clearly enough to be able to state that with authority in this webinar.
We do have members from the team in the chat, so if you want to chime in on that question, that would be super helpful. So John, next question. If rewards are given every day, what happens if there are no proposals in a given day?
That's also a very good question. I don't know whether that would count as 100% for the day or if it would have no reward for the day. Another good question for the NNS team.
Cool. So if the NNS team answers in the chat, I'll also verbalize it so anyone watching on YouTube will be able to know the answer. Next question, John. Does the governance canister hold ICP? Because I thought canisters cannot hold ICP.
The governance canister does not hold ICP. That is held in the ledger. What the governance canister is able to do is that it is able to request to the ledger canister that it transfer ICP.
Great. Next question. Can I theoretically increase my voting power by increasing the number of neurons I follow, like if I followed every single neuron in existence?
That's a good question. No, this does not increase your voting power. If you were to follow 10 neurons, you would simply vote as the first neuron votes within the tree of those followees. So let's say that I follow 2 neurons, one of them votes yes, one of them votes no. I might follow the one that votes yes, I might follow the one that votes no. It all depends upon how that followee relationship is structured in the code. So you will only get one vote ever.
Cool. Next question. Are there types of proposals that are not voted upon by all categories of neurons, or are they all fair game to be voted upon?
I believe that if you set the Dfinity Foundation as a followee, you will not vote on the topic that allows changing of neurons. You will vote on all of the other topics. And we did that as a safety mechanism to make sure that people didn't inadvertently vote on topics that could alter their own neuron.
So other than the NNS app, what are the other ways in which I can create or manage neurons?
At the moment, there are two principal ways that you can create a neuron or stake one. The NNS app, as mentioned. We also have a command line utility. It's on GitHub under Dfinity/Quill. And Quill is our command line staking utility. Really, all that Quill does is it constructs properly formatted messages for the internet computer and transmits them with your signature using your private key. And this is, for example, how I personally stake neurons. It's what I've been recommending to a lot of people if they have access to an air-gapped computer and want the most secure solution possible. But in the future, there will be more. We have a Ledger Nano app currently under review by the Ledger App Store. That will be another means of staking neurons securely. And then our custodial partners, such as Coinbase Custody and Signum, they are also working on staking solutions.
Cool, thank you, John. So what are the benefits of why did we design the neurons to be able to be in a state of dissolving or non-dissolving and not have all neurons be dissolving by default? Is this due to security reasons, for example?
I don't know why, but a person who has a non-dissolving neuron is simply very clearly expressing the fact that they intend to be a long-term stakeholder. And so we incentivize or reward this condition by giving that age bonus that I talked about. Not everyone wants to race to liquidity, so to speak, the moment that they stake.
Cool, thanks, John. Next question, who is the intended audience for staking? A lot of this is quite technical and complex for people to be able to understand.
I think the audience for staking really is everyone. It's a UX concern at the moment. Yes, it is complicated, unfortunately, which is why we don't have very large numbers of stakeholders at the moment. But in the future, do look for wallets and other solutions to come online that will make this all a much, much easier, clearer, easier to understand process. These are early days.
Yeah, exactly. So John, if somebody were to have issues around the NNS app or around the internet identity, what's the best way to troubleshoot the issue?
Reddit is a good place to ask questions. support@dfinity.org is another email address you can use to ask questions. I read Reddit every day, so I will see your NNS questions if you post them there. And if there are questions that I can't answer for you right away, I forward them to the NNS team and we get those resolved. It's very, very important to all of us that governance be very stable, secure, and well understood.
Thank you, John. I like the next question. It's a bit more conceptual, but is around the NNS. So how can we confirm that the NNS is actually decentralized?
That is a great question. Well, the NNS only evolves through proposals. So the amount of centralization relates to who is the biggest stakeholder. And as stakeholders increase and multiply throughout the world, that will cause decentralization of the NNS.
Cool, I think that's a good answer, John. So the next question is around the NNS app, but also internet identity. So let me know if this is something that you'll be able to answer. But so let's say I have my seed phrase with the internet identity, but I lost the device tied to my seed phrase. So does that mean that I've lost control of my neuron?
If you created your neuron through the NNS app, and if you have lost all of your means of authenticating into internet identity, then yes, you have lost access to that neuron.
Okay, got it. And then let's take a look to see if there are any new questions that have come through in the Q&A. So we did actually have a couple of questions come in the time that we were chatting. So what do you think about unlocking ICP in proportion to the dissolve delay instead of unlocking all of the ICP at the end of the dissolve delay, I wonder if there would be a significant difference in behavior between the two options.
If I understand correctly, is the person asking about the ability to unlock portions of the stake?
This individual can clarify in the chat what they meant, but let's proceed as if that is what they meant.
Okay, in that case, this is really what the splitting functionality is intended to provide, rather than adding any further complexity to the expression of and calculation of dissolve delay.
Cool. So I see there's a question in the Q&A, which I think would be better actually for the Cycle DAO chat next week. But just to verbalize for everyone here, won't tools like Axon create a secondary market for neurons in any way? So I know Norton is here. If you want to answer that in the chat, you definitely can field that. Cool. Another question. Is there a plan to make public on the NNS the total number of staked ICP, neurons by years staked, and so on?
That's a great question. Some of the information about neurons and about their internal details is private to the holder of that neuron. So this is something I would have to defer to the NNS team in terms of how much visibility they want to allow into the conditions of our stakeholders.
Great, thanks, John. Cool. So one question, what efforts is Dfinity Foundation making to make the voting more decentralized, such as perhaps there are, individuals with neurons who are experts in certain fields, and really, is there any way to highlight who is good for what when you're looking to follow neurons?
Well, those large stakeholders who are experts in different domains, I would encourage them to advertise that and to publish their neuron ID and invite others to follow them. That type of decentralization, I think, is best driven outside of the Dfinity Foundation and done as a community collaborative effort, simply because this is an egalitarian system. Everyone who is a stakeholder at the same amount of stake is equal to every other stakeholder at that amount of stake. So it's really up to the stakeholders to take charge of this themselves.
Cool, thanks, John. I know we were coming up at time. Just as an FYI and for visibility, we did get a couple of questions around taxation of neurons, but since neither John nor I are tax experts, and we also do not know your individual circumstance, which is based on your individual jurisdiction, we are unfortunately unable to answer those questions. So we have, maybe 30 seconds left. If anyone has any last minute questions, feel free to drop that in the chat or in the Q&A. But otherwise, it's been a very, very lively and dynamic discussion. I've personally really enjoyed seeing what topics that you are all curious about. I'm sure John is having a blast. John's our resident expert. John, you got a lot of compliments in the chat around your slides. We were joking about making NFTs out of some of your slides because they're so beautiful. Okay, so I don't see any further questions. So let's go ahead and we can conclude for today. So thank you so much, John, for this very, very enlightening chat on staking on the internet computer. Thank you everyone who for attending and for all of your brilliant questions and for keeping the chat so lively. So we will see you at the next community conversation. Bye, everyone. Take care.
Bye.